Good evening, everybody. Okay, welcome to the last segment for kinematics. Okay, acceleration due to gravity. Okay, in this section here, we will look at Earth phenomenons. Okay, and we will analyze that particular phenomenons. Okay, using what we have learned previously, which is the graph of motion and the formula of acceleration and velocity. Okay, and we will apply what we have learned to this particular section 2.4 or to this particular phenomenon. Okay, and this phenomenon actually is quite related to our real life. Okay, now the question here we have is that if I drop a heavy object and a light object at the same time, who will reach the ground first? Okay, would the heavy object reach the ground first, or would both of them actually reach the ground first? Okay, the context or the answer to this question actually is that both contexts is possible. Okay, both contexts is actually possible. Okay, the reason is because which of the scenario will happen actually depends on what conditions is available. Okay, is present, which condition is present. If the correct condition is present, okay, both scenario can actually occur one. Okay, so it's possible to have hammer reaching the floor first, or it's also possible for the hammer and the nail, the heavy and the light object, to reach the ground at the same time. It is possible. Okay, and in this section here, we will look at the second scenario. We will look at what is the conditions that allows this second scenario to happen. The first scenario, we will not dwell too much, because first scenario, I think every one of us are quite familiar with it. In fact, in our everyday life, if you drop a hammer and a nail, a heavy and light object at the same time, you actually find that the hammer will reach the ground first. Okay, the heavy object will definitely reach the ground first. Okay, partly because when we drop hammer and a heavy and light object in our daily life, we are dropping in the presence of air resistance. Okay, so if you have air resistance with air resistance, you'll find that it is always hammer, heavy objects will reach the ground first. So that is like quite obvious now. Every one of us, we actually see it in our day-to-day life, and we actually know it. But what happens is that if I am able to take out all the air, and if I am able to suck out all the air, so let's say if I have a vacuum now, if I have a vacuum on Earth, I suck out all the air and I drop the same thing. I drop the heavy object and the light object, okay, without any air, aka no air resistance. You will find that the hammer and the nail, the heavy and the light object, they are literally falling in the vacuum, whereby there's no air resistance. Okay, so when things fall at vacuum, they are falling down on their own weight. Okay, the only force that's acting down on Earth is actually what we call gravity pull, which is the acceleration, the gravitational field strength, the pull of the Earth. And both of them will be subjected to the same pull. And the pull, or what we call acceleration due to gravity, that pull is actually 10 meters per second square, which means that the both objects falling in vacuum without air resistance, they are subjected to the same pull, which means their speed will change at the same rate. So both objects, they will change, okay, at the same rate, and you will find that, okay, both objects, they will fall, or the speed will change at the same instances by the same amount. So every second pass, the light and the heavy object, their speed will change by 10 meters per second. Remember, gravity, acceleration due to gravity, which is what laymanly we call it, the gravity, is 10 meters per second square. Means 1 second, velocity will change by 10 meters per second. So in this case, without air resistance, both heavy and light object speed will actually change by the same amount. Every 1 second, the speed will change by 10, at 10, at 10. So the hammer will increase, the speed will increase to 20 meters per second, and the feather or the nail, the lighter object, will actually be at the same speed, 20 meters per second. So as time passes, even at 4 seconds, okay, you'll find that because they have the same acceleration, they are subjected to the same change in speed. Their speed at 4 seconds is actually the same. And because they have the same speed and they start with the same starting point, you'll find that they will actually reach the floor at the same time, okay, because they have the same speed in this case. So the ultimate condition, or the only condition that you will need to have, is actually the presence of air resistance. If I can actually remove air resistance, I can actually make two objects, heavy and light, reach the ground at the same time. Because in falling in the presence of air resistance, falling in the present, without the presence of air resistance, without the presence of air resistance, both objects are subjected to the same gravity pull, which is the same acceleration due to gravity. Okay, they will be subjected to the same acceleration, which is 10 meters per second squared. And because I know they have the same accelerations, if I have the speed time graph in this case, if I'm going to plot the speed time graph for these motions, you'll find that the gradient of a speed time graph will be a constant number. Okay, don't forget the section 2.2, we mentioned that if velocity time graph, the gradient of the velocity time graph is acceleration. So if I'm saying that the acceleration is constant, I'm also saying that the gradient of a velocity time graph is a straight line or is a constant gradient. Okay, so with these two in mind and the condition in mind, okay, you will find that the falling in mid-air, falling in air without air resistance, the acceleration or the speed change of any object is not dependent on the mass and the size of the object itself. So I can have a heavy one, I can have a big size object. If I versus a small size object or a lighter object, if I drop both of them in air without air resistance, both of them will be subjected to the same acceleration, both of them will be subjected to the same speed change. Their speed will increase by the same amount, and both of them will reach the floor at the same time. This is what we mean by falling in the air without the presence of air resistance. Okay, what we call free fall. Okay, free fall denotes falling freely in air in the presence of gravity only. Okay, in this case, it will be 10 meters per second square, the pull. Okay, nothing else. Okay, no air resistance, nothing. Okay, so the context that we look at is G is constant, the gravity, acceleration due to gravity is constant. Oh yeah, forgot to tell you. Acceleration due to gravity, the symbol here is G. Or sometimes we say A, depends on the question. Okay, and also same thing, we also make references to the need for velocity time graph, which means you need to find area under the graph if needed to. Okay, so in the sense, in this section here, a few things that we look at is, when we look at acceleration due to gravity, the context that we are looking at is always without air resistance. Okay, and the acceleration due to free fall, or the acceleration due to gravity, is always 10 meters per second square. Okay, so this is the two assumptions or the conditions that we are looking at in this context. Okay, in your syllabus, okay, we are looking at falling objects without air resistance. Okay, and the gravity or the acceleration due to free fall is actually 10 meters per second square. Coupled with what we learned in 2.2, you have your speed time graph, which talk about gradient and area under the graph. 2.1, okay, we will talk about the acceleration formula, A equal to V minus U divided by delta T, and the describing of the motion graph. So we will put all this together. You can now solve a standard kinematics question, like what you see on the screen now. This is what we call a standard kinematics question. Nothing easy, not too difficult. It's a basic kinematics question. Okay, not simplified anymore. Okay, so the question will go like this. If I have a object, it drops from height of 35 meters, okay, before landing, what is the speed of the informations? What is the speed of the object before hitting the pile? Okay, from the story, this question maybe is worth around 3 marks. Okay, it looks very, very skimpy, very little information, but actually some information is actually hidden behind. Okay, for example, you know that the object is falling. Okay, the object is fault free. So the moment I say drop, there's the first hint already. Okay, so I want the speed of the object and I have the height 35 meters. These are clues that is given in the question. So how do I interpret them? So for this context, let's say when I say drops, drop has important information. When I say drop, okay, it means the initial speed is actually 0 meters per second. Okay, this is the information behind this word drop. And when I talk about, when you look at the questions, the object is dropping in air. So when it's dropping, it also means that it is experiencing free fall. This information will tell me that the acceleration is actually fixed at 10 meters per second square. Okay, so and when I have the second clue, distance, or to be exact is height, I have the height, which is 35 meters. Okay, height 35 meters with accelerations. These two information will tell me that I will need to draw my speed time graph. Okay, the speed time graph, which is here. Okay, this is the speed time graph. Okay, area under the graph is 35 meters. It means what? What do I mean by this? It will mean that the area under the graph is actually 35 meters. Okay, so what do I do now? Okay, so with these two information, I will know that the distance under the distance under the graph is 35 meters, which is half base times height. So the time taken is base is the time, the height is the velocity. So this is 35. So if you rearrange the equations, you will find that the first equation you will see is Vt is 70. This is the first equation. Okay, now we move on to the second or the other part of the question. With this equation, you still can't solve anything yet. Okay, but there are still other information hidden behind. Okay, let me erase this first. So now what we do is speed time graph. The next thing I look at is the gradient. Okay, yeah, I know that the gradient of the graph is acceleration. And based on the question, I know acceleration is 10 meters per second square. Okay, and what's the formula for acceleration? Okay, 2.2 mentioned is final minus initial divided by time. Okay, so remember the question is asking about finding velocity speed of the object. So from here, I know that the initial speed u is 0. Okay, so time is t, which is 10. If I rearrange the equation, it will be v equal to 10t. Okay, so this is the second equation. So now with two equations, you can do a simple substitution. Okay, so let me rearrange this equation. Vt is 70. Indirectly, I'm saying t is actually 70 divided by 5. Sorry, not 5, sorry. 70 divided by v. My mistake. Okay, so now what I do now is I will substitute this into the equation. So v will be 10 over 70 divided by v. So this will bring me to be v squared will be 700. And if you do a simple square root and you use your calculator, you will find that v is actually 26.4 meters per second. Okay, question solved. Okay, so in this context here, we are using actually free fall. The context of free fall, speed time graph, gradient, area and the graph, everything together. Okay, just that the important thing that you have to take note is that when you look at the questions, keywords like drop, height, they have certain meaning behind it. They have certain clue behind it. So you need to sieve out the correct clue or the necessary clues for you to solve. Okay, so in this case, okay, this is where I have to end off, okay, because this is where you need to actually put down the phone or the laptop and actually get onto your workbook or your resource package or your worksheets to actually try out the method of solving. Okay, the method of solving is actually quite standard. VT graph, find area, find gradient, then followed by the free fall acceleration equal 10 meters per second square. So this only with more practice, then you will be able to sieve out the information fast, do the math fast and accurate. Okay, if you have nothing much, okay, if you got any comments, just let me know. Okay, type your comments at the comment bar below or drop me an email. Okay, if I have anything need to improve, okay, feel free to drop me an email also or write on the comment bar also. Okay, new video will be uploaded. Okay, if you need to get any updates, okay, remember to subscribe to the channel and to get press the notification bell to get updates. Okay, if not, thank you. Bye bye.